Hello my dear students, this is the fourth video of the chapter Triangle for class 9. If you have not watched the previous videos, please do watch the previous videos. We have already discussed the properties of isosceles triangle. In this video, we will solve some problems based on the property of an isosceles triangle. Let us see the first question. Triangle ABC and triangle DBC are two isosceles triangles on the same base BC, and the vertices A and D are on the same side of BC as given in this figure. If AD extend to intersect BC at point P, then show that triangle ABD is congruent to triangle ACD, which is marked by blue color. Triangle ABP is congruent to triangle ACP. Third part, AP bisects angle A as well as angle D. Fourth part, AP is the perpendicular bisector of side BC. Let us solve the first question. Here given that AB is equals to AC and BD line is equals to CD. Because these two triangles are isosceles on the same base BC, it is already given. So in the first part, we have to show that ABD triangle is congruent to triangle ACD. In triangle ABD and triangle ACD, can you find out the three things which are exactly equals to each other? Yes, of course, AB is equals to AC, already given. In triangle ABD and ACD, what else you can observe? Yes, it is BD is equals to CD. Can you find out the third thing? Yes, by reflexive property, we can write down AD is equals to AD, which is common in both the triangle, and the first was already given. What are they? They are all sides. So which congruency? So triangle ABD is congruent to triangle ACD by SSS congruence condition. So here your first part is done. Let us move. So here again we are going to use AB is equals to AC and BD is equals to CD. Since in the first part we have already shown that triangle ABD is congruent to triangle ACD. So can you write down angle BAD is equals to angle CAD? Yes, you are right by CPCT. Corresponding part of congruent triangle concept. So now we have to find out three parts in the triangle ABP and the triangle ACP. How observant you are. Can you find out the three things? The first is AB is equal to AC. That is already given. BAD is equals to angle CAD. This we are going to use here. BAP will be equals to angle CAP. Can we write down this? Yes. We have already proved this in the first part. And the third property is the reflexive property, that AP is equals to AP is your common side in both the triangle. So you can write down triangle ABP is congruent to triangle ACP. Here the congruence condition, can you identify? This was your side, this was your angle, and this was your side. So here the condition was SAS congruence condition. Let's check the third part. AP bisects. Now again let us recall the term bisects. Bisects means that line segment AP divides the angle A in two equal measures. So can you now write down AP bisects angle A? Yes, since we have already shown that triangle ABP is congruent to triangle ACD, so by simplicity we can write down angle BAD is equals to angle CAD. That is, concept is CPCT, corresponding part of congruent triangle, and in the fourth part, uh, AP is the perpendicular bisector of BC. How can you show this? We have already shown angle BAP is congruent to triangle CAP. So, can we write down angle BPA is equals to angle CPA by CPCT? Let both are equals to x. Since BC is a straight line, can you write down BPA plus angle CPA? Both are equals to 180 degree by linear pair axiom. So x plus x is 180. So what will be the measure of x? This gives you 2x equals to 180 degree. So x is 90 degree. Hence, AP is the perpendicular bisector of the side BC. Now move to the second question. Two sides AB and BC and median AM of one triangle ABC are respectively equal to the sides PQ and QR, and median PN of triangle PQR. Show that triangle ABM is congruent to triangle PQN. The second part is triangle ABC is congruent to triangle PQR. So what we have given with in this question? In this question, we have given that AB is equals to PQ, BC is equals to QR, AM is equals to PN, where AM and PN both are the median. What do you mean by the median? Median bisect the third side. That means this line PN divides the third side in equal parts. So what we have to prove is triangle ABM is congruent to triangle PQN, and in the second part triangle ABC is congruent to triangle PQR. Let us prove the first part. So take in triangle ABM and triangle PQN. Can you observe the three values, three parts which are exactly equals to each other? Yes, the first part AB is equals to PQ. The second part you can write down AM is equals to PN. In the third part, complete BC is equals to QR side. So, if you multiply half in both the sides, then the result will also be equals to each other. So, half of BC can we write down that it is BM because AM is a median, and half of QR is equals to QN because PN is a median. So this is side, this is also a side, this is also a side. So triangle ABM is congruent to triangle PQN by SSS congruence condition. I hope now the second part you will do it by your own. This is your homework. Now let us do one more question. Triangle ABC is an isosceles triangle which side AB is equals to AC. Draw AP perpendicular to BC to show that angle B is equals to angle C. This is a theorem which we have done in our previous video. In that video, we have done by constructing AP as angle bisector. But in this question, the difference is that here AP is drawn perpendicular to BC side. Let us now prove the congruency in triangle ABP and triangle ACP. Can you observe the equal sides or equal angles? Yes, the first one is already given, AB equals to AC. AP is equals to AP, which is common. And the third one is, which is already given, AP is perpendicular to BC, means angle APB is equals to angle APC, each 90 degree. So can we now write down that ABP is congruent to triangle ACP, but by which congruency? This is your right angle, this is your side, and this is clearly it's your hypotenuse. Yes, you are correct. This is done by RHS congruency rule. By all these questions, I hope now the properties of isosceles triangle is clear to you.